Hello, my name is Dr. Gary Edgington, Senior Polymer Scientist for Cellular Bioengineering. Thank you for your interest in DeconGel. The development of DeconGel, funded by the Air Force and the Hawaii Technology Development Venture, has taken more than 2 years. Full-scale production of this product line commenced in October 2007. Currently, radioactive spills and contaminated surfaces in hospitals and laboratories are commonly cleaned with absorbent wipes and soap, resulting in a large amount of waste. The process is often repeated several times due to the poor efficacy of this outdated method that often requires a significant amount of time scrubbing, wiping, testing, and repeating the process until the required limit is reached. In this video, we will demonstrate how DeconGel can be used to improve the efficacy of your decontamination procedure while concurrently reducing the total staff hours required and the volume of waste generated, thus reducing the total cost of the process. DeconGel is a safe, low-odor, water-based product capable of removing and encapsulating various types of contamination, including radioisotopes, hydrophobic, hydrophilic, and particulate contaminants. It is recommended for use in hospitals, laboratories, nuclear power plants, decommissioning of nuclear support facilities, and industrial environments. DeconGel has undergone extensive laboratory testing demonstrating that it can efficiently remove a variety of radionuclides from a variety of surfaces including glass, metal, painted surfaces, tile, grout, and even bare concrete. Simply apply DeconGel with a brush, trowel, roller, or power sprayer. Allow it to dry, then peel away the film. The gel penetrates into cracks, crevices, pores, and voids of smooth, rough, and coated surfaces. DeconGel uses a variety of strategies and components, including chelators, to bind contaminants and draw them into the film. Contaminants are entrapped in the semi-crystalline polymer matrix as the film dries, allowing the contamination to be safely transferred to an appropriate containment vessel. I would now like to present some field testing showing the effectiveness of DeconGel. The first example is the decontamination of iodine-131 in a thyroid cancer treatment room at Tripler Medical Center in Honolulu, Hawaii. DeconGel was applied with a common paintbrush to contaminated areas on the sink, counter, bedside floor, and bathroom floor. The gel was allowed to dry overnight and peeled the next day. The decontaminated areas were evaluated by swiping the surface and testing the swipe in a gamma counter. The percentage decontamination ranged from 96 to 100%. Notably, the peeled films were tested directly. First, the films were tested with a Geiger meter showing the films contained a significant amount of I-131, with readings ranging from 300 to 44,000 counts per minute. Next, both the tops of the dry films as well as the contact sides were swiped, and the swipes tested to determine the amount of I-131 that could be removed from the surfaces of the film. Results ranged from 0 to 29 counts per minute, showing almost complete encapsulation and containment of the radioactive I-131. This is in strong contrast to the traditional wiping and scrubbing with various solutions that essentially spread the contamination over a wider area. The wet contaminated rags and paper towels transfer the contamination to anything they touch, whereas dry DeconGel encapsulates the contamination. DeconGel was also evaluated by Colorado State University. A chemistry lab fume hood had been contaminated when tritiated thymidine was volatilized during a lab experiment, resulting in decommissioning of the hood. For approximately 4 years, the hood was decontaminated almost every month. The contaminated areas were swiped and measured in a liquid scintillation counter. Before decontamination with DeconGel, the contaminated areas ranged from 10 to 1,920 counts per minute, even after 4 years of monthly cleanings. DeconGel was applied and allowed to dry. To enhance the ability of DeconGel to draw out the contamination from deep within the semi-porous substrate, the gel was left on the hood over the weekend. After removal, the hood was tested showing almost complete decontamination. It was tested again after 11 weeks showing that the hood was still clean and that the leaching that took place after every previous cleaning had been controlled. Decontamination with DeconGel resulted in the recommissioning of this university chemistry hood after being decommissioned 4 years earlier. The last efficacy example I would like to present is testing performed by Sandia National Laboratories. Concrete, carbon steel, stainless steel, and plexiglass were contaminated with acidic solutions of cesium-137, americium-241, and plutonium-239 under controlled laboratory conditions. The surfaces were swiped and measured with a gamma counter. More than half of the substrate isotope combinations were decontaminated with greater than 90% efficiency, and the concrete americium and concrete plutonium combinations showed an impressive 71 to 83% decontamination. Decontamination with DeconGel was repeated on these same samples, resulting in similar decontamination efficacies on these previously treated substrates. DeconGel is offered in several different viscosities, optimized for different application techniques. A higher, non-sprayable viscosity is usually preferred for brush, roller, and trowel application. These application techniques usually require only one coat to achieve good peel performance. Porous vertical surfaces, such as concrete, can require more than one coat. High viscosity versions also provide greater coverage per gallon, resulting in the best cost per square foot decontaminated. DeconGel can also be supplied at viscosities optimized for professional-grade high-pressure airless spray equipment, and separately for a common handheld airless sprayer such as a Wagner Power Painter, commonly available at building supply stores. One simple method of applying DeconGel is with an ordinary paintbrush. The gel can be squirted directly from the bottle or dipped into an appropriate container and applied to horizontal, vertical, and complex-shaped substrates. We also recommend the use of disposable trowels to quickly coat floors or other flat horizontal surfaces. A 16th-inch V-tooth trowel will lay down about a 10 to 15 mil wet film that, when dry, will peel well from most non-porous and semi-porous substrates, as well as some porous substrates such as sealed grout. For more difficult substrates, such as smooth bare concrete, a 3/16-inch tooth trowel that will apply approximately a 20 to 25 mil wet film is recommended. And for poor quality or rough concrete, a 3/8-inch tooth trowel is recommended. Additionally, a long-handled trowel can be used to quickly coat large areas with the recommended film thicknesses of non-sprayable versions of DeconGel, optimizing cost per square foot. The use of brushes, rollers, and trowels to apply the gel provides greater control than airless power sprayers. These tools produce peelable edges, may provide easier equipment cleanup, avoid the potential need to tape off the area, and eliminates overspray. On the other hand, spray application offers important advantages over these tools. Spray application can quickly coat both simple and complex shapes and is preferred for many end uses where fast, broad area coverage is important. We offer a viscosity grade optimized for a handheld airless spray gun such as a Wagner Power Painter Pro equipped with a high viscosity tip. Smooth, non-porous surfaces may only require one coat. However, most surfaces require 2 to 4 coats on vertical and inverted surfaces, with most applications requiring 2 or 3 coats. For best results, apply a light blue layer with care to prevent sagging. Sagging does not hurt efficacy, however drips and pools take longer to dry. After 2 hours, apply a second coat equal to or slightly thicker than the first. This can be repeated after about 1 hour for the third coat if required. We also offer a higher viscosity sprayable grade optimized for a 3300 psi professional airless sprayer. Begin with a 21 thousandths tip. This combination is recommended for high volume, broad area coverage, providing thicker wet films per coat on vertical surfaces and significantly faster application than either hand tools or a handheld airless spray gun. When utilizing spray application, it may be desirable to tape off the treatment area. Taping prevents overspray on surfaces that do not need to be decontaminated and creates a peelable edge. The taping is not always necessary because DeconGel is essentially a solid soap that can easily be scrubbed off with water and a scrub brush or scrub pad. When utilizing any application method, it may be advantageous to use a buddy tab. A buddy tab is simply a piece of tape that can be coated over and left in place while the film dries. The tape can then be used to easily create a leading edge, This technique is especially useful on porous concrete to which the DeconGel has good adhesion. For most surfaces, plastic, metal, or wooden scrapers can be used to start the edge. The selection is usually determined based upon the sensitivity of the substrate to scratching. For example, a wooden paint stirrer is ideal for starting the peel on linoleum tile. Also note that deep cracks and voids inhibit the evaporation of water. If the gel is not fully dry inside the void, that portion can be left behind during the peel. As a result, the surface area associated with that portion of gel will not be decontaminated. It is essential to observe such surface architectures and ensure the film is dry for best results. Note that DeconGel contains a blue dye. The dye allows the user to visualize the wet film thickness. The wet film will need to have an obvious blue color to provide a dry film that peels easily from most substrates. Dry times vary with wet film thickness, type of surface, temperature, and humidity. Dry times can be as short as an hour for thin films on a non-porous surface, such as glass, to more than 24 hours for thick, wet films applied to bare concrete. In most cases, overnight is sufficient for good peel performance and efficacy. If you apply a film that is too thin for your application and have difficulty peeling it, simply reapply a thicker coat on top of the first layer, let dry, and peel. Please note that DeconGel has been shown to peel off of a wide variety of substrates. If peel performance is not adequate in your specific job, simply increase the dry film thickness with additional coats, ensure the gel is dry, and peel. Please contact Cellular Bioengineering to review any questions you may have regarding recommended product and application techniques. Our technical professionals can provide additional information regarding the best approach to address the wide variety of surfaces, isotopes, application conditions, and environmental conditions that may be encountered. To request information or to order DeconGel, please call 808-949-2208. Again, thank you for your interest in DeconGel.